Let's jump right into chapter 21. Confidence intervals, remember confidence intervals? For the differences of two proportions. We often want to know how two groups differ, whether a treatment is better than a placebo, whether this year's results are better than last year's results, whether men are better than women, whatever. Comparisons between two percentages are much more common and interesting than questions about isolated percentages. So all of last graded period, we were concentrating on calculating things based on isolated percentages. Now we want to base it on two or more. So we're going to be comparing. A survey was taken randomly select Americans aged 65 and older, which found that 408 of the 1,019 men and 530 of the 1,054 women suffered from some form of arthritis. So we're comparing men and women who are 65 and older and whether or not they have arthritis. Let P1 be the sample proportion of senior women. So my first value here, I'm going to look at women suffer from arthritis, and P2 be the men. It's very important you get these lined up correctly. So notice we're comparing women to men. Create a 95% confidence interval of the differences in proportions of the senior men and women who have this disease. All right. How do we do this with just a single proportion? Well, we went to the calculator. You went stats, tests, and can you remember which test did we go to? Oops, stats, test. And we went to one proportion Z test, right? For just one percentage. Now, guess what? Now we're going to go to two. So B, two proportion Z interval. And I have my X1, N1. So my X1 value will be what? Since I'm calling P1 women, I want to look at the women, which is right here. Which of these numbers would be your X1? Yeah. 530. That's going to be my X1. So I'm going to type in 530. What's going to be my N1? What's my N value for women? 1,054. So let me go 1,054. And what am I putting for my X2 and N2?
The 408.
Okay, very good. 408 for X2. And N2 will be the 1,019. I want to see a confidence interval for what? 95%. So what do I put here?
0.95.
0.95. Very good. And calculate. So there we go. My interval is roughly between 6% and 14.5%. So like here. 'I'll just pick percentages, 6% and 14.5%. That is my confidence interval and then my difference in proportions. So instead of going to A, the one proportion, we're going to now go to B and find the difference between two different percentages. Now what does that all mean? To have a 6% and 14.5. How do we interpret that? What this is saying is there is a 95% confidence that based on these samples here, that the proportion of American women, so the first one I looked at that I called one was women, age 65 and older, who suffer from arthritis is between 6 and 14.5% more than the proportion of American men of the same age who suffer from arthritis. I'm going to say more because these values are positive, right? You don't see any negative numbers in there. which is why it's important you correctly label what's going to be your 1 and 2. If I had put men first, which I'll show you, what do you think is going to happen here with these numbers? If women are more than, then men will probably be what? Less than. We'll see. The part C was, does this suggest that arthritis is more likely to affect women than men? Explain. So if any of these values are less than 0, then yes, this is true. More likely. If you see any negatives in here, then this is false. That's a no. They're not more likely. So let's look. Let's change it around in terms of men. So stats, test, 2 proportionality tests. I'm going to put 408 here and 119 here. And then for here, I'm going to put 530 and 1054. What do you notice?
They're negative.
They're negative, right? So with this value, would you say that, does this suggest that arthritis is more likely to affect men than women? You would say no, because why? Because of the negative. So yes, option 1 is more likely than option 2 if this is all positive. You'll say no, option 1 is not more likely than option 2 if you see any negatives up here. Does that make sense?
Yes.
So let me have you give it a try. Men diagnosed with cancer were randomly assigned to either undergo surgery or not. Among the 342 men who had the surgery, 18 eventually died of cancer, compared to 28 of the 345 men who did not have the surgery. Let P1 be the sample proportion of men who did not have the surgery and died, and P2 be the sample proportion of men who had the surgery and died. Create a 90% confidence interval for the difference of proportions of senior men and women who had this disease. So we're comparing who had the surgery and who did not have the surgery and whether or not they died of cancer. And then work on part B based on the confidence interval. Is there evidence to suggest that surgery may be effective in preventing death from cancer? Where did I go to find this confidence interval using my calculator? What buttons did you push? Stat? Test, very good. And you went down to B. What did you put for X1?
28, right?
18. Let's see who did not have. So P1 is who did not have the surgery. So that was 28. Again, make sure you keep track. Pay very close attention to what you're calling 1 and 2. So out of 28, what was my end value?
345.
345.
18.
And then, yep, this part's 18. And this part is
342.
342. And then what did you have as your confidence interval?
90.
0.9. So let's recap. This is who did not have the surgery, right? I'm basing everything off of comparing 1 to n, who did not have it versus who did. Based on that, would you say that you are more likely to get cancer by not having the surgery?
No.
No. See a negative, right? So let's compare. Yep. Okay. Since the interval does contain a value that's less than 0, there is not any evidence that the surgery may be effective in preventing the death from cancer. Let's see, these are the same values we got, right? Yeah. So it's as easy as that. Do you see a negative or not? If you do, then there is evidence. If you don't, if you do see a negative, there's not evidence. If you don't, if it's all positive, then there is evidence that it fits within that